Swayam Prabha. Digital India. Educated India.
Welcome to Module D, Lecture 6. In this lecture also we shall continue our discussion about analysis of two-lane highway segments as per Highway Capacity Manual 2016. In Lecture 5, I introduced to you about the basic characteristics and uniqueness of two-lane highway segments as compared to other uninterrupted flow facilities, for example, multi-lane highways or freeway segments. Then two-lane highways serve different functions, wide range of functions, and therefore, there are three types or three classifications of two-lane highway segments: class 1, class 2 and class 3. We also discussed about various service measures which should be used to define the level of service for different classes of road. The three service measures which were discussed include average travel speed, percentage time spent following, and then percent of free flow speed. Then the level of service criteria, this was discussed, and the role of passenger capacity and passenger demand in the context of level of service was highlighted. With this background, today we shall see how we can determine the level of service for different classes of highway, particularly two-lane highway segments. As you know, for class 1 road, the service measures are average travel speed in miles per hour and percentage time spent following, expressed as percentage. For class 2 road, it is only percentage time spent following, and class 3 road which are passing through local towns or urban settlements, there we only use percentage of free flow speed. Now, according to that, the flow chart shows how stepwise we can go ahead to determine the level of service for a given two-lane highway segments. It starts with step 1, gather input data. Then the step 2 is estimate free flow speed. These two steps are common for all classes of road. Then, as you know, class 1 road we need to calculate ATS and PTSF. So, what we do, step 3 and 4 are related to ATS and 5 and 6 related to PTSF. In step 3 we adjust the demand by applying necessary corrections with respect to the ATS which are necessary, then estimate the average travel speed. Similarly, in step 5 we adjust the demand, keeping in mind the objective of doing that is calculation of PTSF, then estimate the PTSF. And once the PTSF and ATS are known, then you determine the level of service. For class 2 roads, it is only PTSF. So, step 5 and step 6 are only done, and then step 8. Class 3 road, we need ATS, because if you want to calculate percentage of free flow speed or PFS, PFFS, then actually you need to also calculate the average travel speed. So, here step 3 and 4 as we did for class 1 road, 5 and 6 are omitted, but then using the 3 and 4 and with the knowledge of free flow speed, we can calculate the percentage of free flow speed. and then in all cases once the measures are known, we know the criteria, what measures, what value or values and what they will mean in terms of the actual LOS from A to F. So, we can determine the level of service. Now, let us go ahead with the computational steps. So, each step we want to discuss in details. As you know, the step 1 we gather in step 1 we gather the input data. Mainly two types of data we required. One is the related to geometric data. The second one is related to demand data. So, what comes under geometric data? Obviously, the highway class we need to know whether it is class 1, class 2 or class 3, and this must be provided. There cannot be any default value for that. Lane width we can get it from road inventory or aerial photograph. You may also assume a default value of 12 feet if nothing is given. Shoulder widths we can actually measure based on road inventory aerial photo, or if you want to assume you may assume a default value of 6 feet. Access point density again from the field data or aerial photo we can calculate, and if not, default values are given here for class 1 and class 2 8 per mile and class 3 16 per mile. Obviously, for class 3 it is higher. Terrain type it has to be based on design plan or analyst judgment, and it must be provided. There cannot be any default values which we can assume in this case. Percentage of no passing zone based on the road inventory and aerial photo we can get it. If not, a default value may be assumed as for level terrain 20%, rolling terrain higher 40% and more extremes even 80% in extreme situation, very difficult terrain. Free flow speed it can be from direct measurements or estimated from the design speed or speed limit, and if nothing is known, then BFFS may be based free flow speed may be assumed as speed limit plus 10 mile per hour. Going to the demand data, you need the hourly volume, demand volume. This must be obtained from field data or from modeling or from projection or future forecast, and this must be provided. Directional volume speed again may be assumed or may come from model, may observed from the field. Analysis period normally it is maybe default values of 15 minute, that may be assumed. So, hourly rates are calculated based on 15 minute count. Peak hour factor normally should come from the field data, but if nothing is known you may assume as 0.88. Heavy vehicle percentage also come from the field data, and if not, in a default value of 6% may be assumed. And these are as per exhibit 15.5 of highway capacity manual 2016. The next step or the very next step is basically estimation of free flow speed. There are three ways the free flow speed can be obtained. One and the most desirable one is to get from direct field measurement. So, this is the most preferred one, you simply go to the field and directly measure it. Now, measurement must be taken in the direction of analysis. So, if you are trying to analyze the northbound direction, then we must collect the free flow speed in the northbound direction, and if both directions are to be analyzed, then we need separate measurements in each directions, because the same free flow speed may not be there for both direction, upstream and downstream. And as you know, because since we are telling that it is free flow speed and that too for two lane roads. So, two lane roads the speed may not remain same for a long or for a heavy up to heavy vehicle volume. The speed drop happens more early speed drop is expected. So, we have to really be careful about the flow rate, and as said or as prescribed in highway capacity manual 2016, this must be measured with a flow rate less than 200 vehicle per hour considering both directions, because you know these are two lane roads. So, the operation or speed get influenced at a early stage, at even a lower value of the flow, two-way flow. So, 200 vehicle per hour is the cap, and we must try to measure the free flow speed. If we are actually measuring the free flow speed, then it must be done with a flow level less than 200 vehicle per hour both directions. Now, the second alternative method is again a field measurement, but suppose for some roads you are not getting this range of flow, you are not able to observe, because the traffic demand, because a variety of purposes and functions the two lane highway segments they serve. So, there could be some two lane highways which are really busy, right, and you may not be able to observe a flow level and go and measure the speed with a flow level less than 200 vehicle per hour. So, in that case the actual field measurements is done at higher flow rates. What we do and then how we can use it? We can still use that measured speed and estimate the free flow speed by applying necessary corrections. So, that is what is shown here in this equation. If the FFS cannot be measured at a flow rate of within 200 vehicle per hour, then the measure speed need to be adjusted using this equation. As you can see here, whatever we are getting FSM FM is the mean speed of the sample what you have collected, and then we are applying some correction, and obviously it has to be with positive sign, because the FFS will be higher in that case than what we have measured in the field at higher flow level. So, this correction is applied 0.00776 into V by FHV ATS. So, V is the two-way traffic volume and FHV ATS is basically the corrections in that volume for heavy vehicle, and this will be done as the corrections I shall explain you in the subsequent slide for the calculation of average travel speed. The same correction will be applied here. Then the third method, you can directly estimate FFS if you are unable to measure it, neither up to 200 vehicle per hour or even higher than that, right. So, you are not be able to measure it in the field. In that case, this can be estimated. How? That is shown here in equation 4.13. So, you take the base free flow speed and apply two corrections here, one with respect to lane and shoulder width, and what would be the correction based on lane and shoulder width? That values are given in exhibit 15.7 highway capacity manual 2016, and the second correction relates to access point density. How many access points are there average on an average per mile, and necessary adjustment in mile per hour speed BFFS to be reduced to account for the prevailing condition, and how much the speed to be reduced, you can take it from exhibit 15.8 of HCM 2016. Now, coming to the BFFS, BFFS if you do not know, but if we know suppose the speed limit, then it may be assumed, I have mentioned it earlier also, that it is the speed limit part plus 10 mile per hour, that value may be taken as BFFS, and BFFS minus some speed reduction due to lane and shoulder width correction minus further speed reduction because of the access point density. So, these are the three ways you can actually estimate the FFS, either direct measurement of FFS or measurement of speed, but at a high flow rate, then apply necessary correction, or you can completely estimate it without any field measurements. Then the step 3 relates to demand adjustment for ATS. If I can go back quickly to the master flow chart. So, 1 and 2 are common for all. Now, for class 1 and class 3 we need to calculate ATS. So, how to do the adjustment of demand for ATS, and then how to estimate the ATS, step 3 and 4. So, step 3 it relates to demand adjustment for ATS. and as I said, we require it only for class 1 and class 2, for class 1 and class 3, class 2 we do not require it. So, demand must be converted to flow rates under equivalent base conditions. So, what are the corrections we need to apply? One is the peak hour factor to account for the peak 15-minute flow rate if the overall hourly demand is there as Vi. Then apply application of correction factor with respect to the FG ATS, that means adjustment factor duly considering the terrain, grade and flow rate. It is primarily the grade adjustment factor, but we also consider the flow rate and also consider the type of terrain, and these corrections may be done as per exhibit 15.9 or 15.10 of highway capacity manual. And then one more adjustment factor is to consider the effect of heavy vehicle. Now, this heavy vehicle adjustment factor, and remember that I have written it heavy vehicle adjustment factor for ATS, demand flow rate, this is the adjustment for ATS estimation, because PTTS estimation also, for PTTS estimation similar corrections need to be done. The formula may be looks very similar, but actual the values are very different, at least sometimes they are different. So, that is why it is written. So, similar heavy vehicle adjustment may be done for PTTS, and that we will write as FHV PTTS, and when we are doing the similar adjustment for ATS, we will write FHV ATS. Now, to do the FHB ATS, this is the equation. You are familiar with this equation, you know that we need to consider the passenger car equivalency, and here two types of vehicles are considered, the recreational vehicle and the trucks or the heavy commercial vehicles. Now, where from we will get the value of ET and ER, that is the passenger car equivalency, that the passenger car unit or passenger car equivalency PCE or PCU values are to be obtained. We can get it from exhibit 1511 or 1512 and 1513 or 1513 as the case may be, depending on the context, and we may have to also calculate or get the value using directional demand, terrain, grade, grade length, all these factors may have to be considered, depending on which exhibit is actually applicable and from which exhibit we are actually taking the value. And then PR and PT are the proportions. So, you get this ER and ET values, proportions are known. So, you calculate this FHB ATS. Once you calculate the FHB ATS and you know the FG ATS, the grade correction factors, of course, considering the terrain and flow rate as well, and the peak hour factor is known, then you can convert this volume Vi, what you are given as input, to an equivalent flow rate under base conditions. Then estimate of, we can do the estimation of average travel speed using this equation 416 as given here. What are the corrections we need to apply? One is with respect to the volume. So, obviously, FFS minus some constant or coefficient into volume. Now, this since it is a two lane highway, so the two-way volume are to be taken. So, we are considering the demand flow rate in the analysis direction, that is indicated as this VD ATS, and also the opposite direction VO ATS. Now, wherever in other cases this is for ATS, calculation of ATS. So, everywhere this ATS is also mentioned, not only VD or VO, but VD ATS and VO ATS. So, this is the volume related correction, and then another average travel speed will get impacted by the percentage of no passing zone, that is very important for two lane road. So, this is the FNP ATS is the adjustment factor, and the values will be always mile per hour, because FFS minus this. So, all these reductions are in mile per hour. So, depending on the percentage of no passing zone, right, but here considering the FFS and also opposite demand flow rate, opposite demand flow rate matters a lot for the to get the number of no passing zone. So, these are to be obtained from exhibit 1515 of HCM highway capacity manual. Now, that is 3 and 4. So, if I go to the flow chart again, so we have talked about step 3 and step 4, which is required for class 1 and class 3 highway 2 lane highway segment. Now, we shall see how we can calculate PTSF, percentage of time spent following, and these are step 5 and step 6, and these are applicable for class 1 and class 2 road, not required for class 3. So, here also again the demand adjustment has to be done following nearly similar procedure what we have described for the ATS calculation, but the correction factors will be different, because the objective is different, where we are trying to calculate the PTSF and there we are trying to calculate ATS. So, the way the heavy vehicles, grades and everything impact the ATS and the way they impact the PTSF exactly is not same. Even the equivalency for the trucks and recreational vehicles are also not same. So, let us go back there and see how we can calculate it. So, that is the step 3 demand adjustment, and step 4 we have done. Step 5 is demand adjustment for PTSF. As I said, it is only done for class 1 and class 2 segments, and the formulas look very similar, only here as you say FG PTSF, earlier case when we did it for ATS, it was FG ATS, that means the grade correction for the calculation of ATS. Now, the grade correction for calculation of PTSF. Similarly, FHB PTSF, earlier case it was FHB ATS. That means, that was for what is the effect of heavy vehicle, how we consider that effect when we are trying to calculate the average travel speed. Now, same effect we have to consider, but the corrections values and everything, even the passenger car equivalency values also are not going to be same. So, this correction actual value will be different, that is why it is called FHP PTSF. So, here also you can see the PHF peak hour factor directly you can get, and if HV PTSF is the heavy vehicle adjustment factor, for that we again use this equation 418, ET ER value these are to be used, and PT PR proportion of truck and proportion of recreational vehicle to be used, and this ET and ER you can calculate it from, get it from directly from exhibit 1518 or 1519 considering other things, and this FG, the grade adjustment factor, that may be obtained from exhibit 1516 or 1517, which case is matching, accordingly we will pick up the table. Now, estimation of PTSF. PTSF we are estimating what will be the percentage time spent following. It is what is the base percentage of time spent following, there is a base value by default, right, that has to be there, plus there will be additional percentage time spent following, right. How this additional value can be calculated? It may be calculated depending on what is the percentage of no passing zone, applying the necessary correction factor and considering the volumes. So, that is what is done here. So, BP TSF D is the base percentage time spent following, and the D indicates analysis direction and O indicates the opposing direction. And FNP, as I said, PTSF is the adjustment factor for no passing zone. This can be taken from exhibit 1521, and how we can get the base percentage of time spent following, use this equation 420, and where again you can see there are two coefficients, D is the direction of analysis. So, A and B are the actual coefficient, VD values can be calculated given the value of VI. So, this is the 420 is the equation that can be used here to calculate this base percentage time spent following. Now, A and B are the constant, these values again may be taken. So, exhibit 15, 20 is there and you can get the value of A and B depending on the context. Now, once you have done that, then you can calculate then PFFS also, which is required for class 3 road, right, and this is for class 3 highway, because there we use service measure as PFFS. So, average travel speed is known divided by free flow speed. Now, at this point step 8, all the service measures as relevant for the class of road, particular class of road, you have calculated measures or measures as the case may be. Class 1 2 measures, other case 1 1. So, you have calculated. Now, the threshold values are given, what value of service measure means what LOS. So, accordingly you can calculate LOS. One small confusion could be there, that for class 1 highways there are 2 service measures. So, you may one service measure may indicate one LOS, another service measure may indicate another LOS. So, what value we will take, and there we are saying the worst of the 2 is the prevailing LOS. So, in one case if you are getting C, another case if you are getting D, then you will assume the overall LOS you will interpret it as D. Now, let us take a small example to see how we can calculate it. This is an example of class 1 2-lane highways segment, and every input is given, demand volume is given in both directions with a 50-50 split. So, equal upstream and downstream, 50% no passing zone, PHF value is given, it said that it is in rolling terrain, that will be useful. The trucks and recreational vehicle percentage is given, 11 feet lane width, 4 feet usable shoulder. So, lane and shoulder widths are given, access point density is given 20 access point per mile. What is the FFS value, what is the base free flow speed value, that is also given, and it is a 10-mile segment length. So, all input that are given. First step is to estimate the BFFS, straightway we are using equation 413. Now, this BFFS value is 16, what we need to calculate FLS, we straightway go to exhibit 15.7 and we know the lane width and shoulder width. So, lane width is 11 feet, 4 feet is the shoulder width. So, we know that the speed reduction has to be 1.7. So, we get that 1.7. Access point density, we know 20 access point per mile. So, again go to exhibit 1518 accordingly, and with 20 access point we know the reduction is 5 mile per hour. So, we get that value, and once we have taken the value from exhibit 7 and 8, then we can calculate FFS equal to BFSS 60 minus 1.7 minus 5. So, you get it as 53.3 mile per hour. Step 1 is 2 is done. Then we go to step 3, equation 4.14 I have reproduced, but here you know the demand is 50-50 split and overall 2A demand is 1600. So, 800 vehicles per direction, and using exhibit 15.9 for rolling terrain and one direction and demand flow rate. What demand flow rate? This is not 800. This demand flow rate is considering the peak hour factor. So, we know that 0.95 is the peak hour factor. If you go there, you see this peak hour factor is 0.95. So, considering the peak hour factor as 0.95, what is the equivalent vehicle volume per hour is 842. So, in exhibit 15.9 we need to give this value 842, not 800. So, 15.9 we give 842, we know for 800 it is an rolling terrain it is given. So, 0.99 and 0.01. So, we round it up to the nearest 0.1 and take a value of 0.99 only, which is given here. Now, the other correction is the heavy vehicle adjustment factor. So, for that one we know the flow is 842 and we go to exhibit 11. So, we take the passenger car equivalency value, say for recreational vehicle rolling terrain it is always 1 point all flows 1.1, but for truck 800 1.4, 900 and above 1.3. So, our values are 842. So, we get the value as 1.4, again nearest 0.1. So, now we use this formula to get the FHB for ATS calculation, put the values, calculate it as 0.943, and then we can get the volume adjustment in the direction of flow and also in the other direction. Each cases it is 800 divided by PHF 0.95, FG it is grade adjustment factor is 0.99 and heavy vehicle adjustment factor we have just calculated as 0.943. So, you get 902 PCU per hour. So, now we can calculate ATS. For calculation of ATS, you know that we use equation 4.16. So, what we need to calculate here FD, VD ATS and VO ATS, these are known 902. What we need to calculate is basically FNP ATS, right. So, no passing zone. So, for no passing zone adjustment factor we use exhibit 1515 as I have shown here, and we know that FFS is 53 mile and we have 50% no passing zone. So, there are one column which is for 55, one for 50. So, you have to take two values for two speed FFS value and then get it, interpolate it to get the value of for FFS 53.3. Similarly, no passing zone 50%, but here we can get no passing zone 50%, right. So, directly we can get it, right, and the flow value is 902 is not given. We know the flow value is given as 800, 900 and then 1000. So, we can interpolate it again get the value for 902. So, first we do it for 55 FFS 55 mile per hour, interpolate 800 and 900 with get the value as 0.8. Here again for 50 we get interpolate the value between 800 and 9000 to get the value for 902 as 0.65. Then we know for 55 it is 0.8, 50 it is 0.65. So, for 53.3 what would be the value, and that altogether you calculate it as 0.7. So, once it is known, so we know then FNP ATS, no passing zone what adjustment to be done, volumes are known 902 in each direction and same in both direction. So, simply use this equation and you can get it as 38.6 mile per hour. Now, the next step is determination of percentage time spent following. So, for that again we need to do the volume adjustment factor, very similar, but only the correction factors will be different and we have to refer to different exhibits to get the pick up the value. So, here also for exhibit 1518 if you see. So, the here also again for all flows here it is 1 and here 801, 900 greater than 900 is also 1. So, does not matter in between also for 842, where from 842 has come 842 you got it by applying the peak hour factor, right. 800 was the flow original and adjustment you have done based on 842, that is the value is to be which is to be used. So, you get it both cases it is 1. So, you get ET equal to 1, ER equal to 1, you use this equation, proportion is known, percentage of truck and percentage of recreational vehicles are known. So, you can actually calculate this correction factor which is also coming out to be as 1. And then the FG value, for calculation of FG value we can refer to exhibit 1516 and here for 842 what is the value, rolling terrain 0.99 and 1.00. So, nearest 0.1 up to that we take it. So, we again take the value as about 1. So, in this case you are getting the equivalent volume as 842 passenger car per hour. Now, estimation of PTSF, for that first we need to calculate base PTSF in the direction of analysis. So, base PTSF, it is this equation. So, this equation number is wrong, it is actually we are referring to this equation. This will be this equation 4.20. So, use equation 4.20 to get this value. So, we know referred to exhibit 1520 what is the opposing flow rate, and accordingly what will be the coefficient of A and B, we pick up that, we calculate it, right, put it and calculate it, we get that base percentage time spent following is 71.3%. And once you have calculated that, then this is the equation which we have to refer finally, and here we have calculated this part as 71.3, and here we need to calculate this correction factor FNP PTSF. Now, what is the FNP PTSF? This is actually taken as 21, where from you have got it, considering that 50% no passing zone and 50-50 split, right. So, and a total 2A flow of 1684. So, 2A flow 1684 if you take, and if you take 50% no passing zone, then 1400 and 2000 2A flow rate. So, we have taken interpolate it and you calculate the value as 21. So, now you get it PTSF is 81.8%, and then we can go to the next step is the LOS calculation, and we can use this exhibit 15.3 HCM 2016. I have also mentioned this about this table in the previous lecture, lecture 5 of this module, and you can pick up. So, if you take ATS as 38.6 average travel speed per mile per hour, then you can get it what is the it is level of service E, and PTSF as 81.8%, you get again LOSC. So, here actually this is the place where we have calculated 81.8, right, the same steps. So, both cases it is saying level of service is. So, the overall LOS is. What you can notice that this 2A highway segment as described is expected to operate poorly because level of service is already E, but the demand is only 842. That shows that the 2A 2-lane 2A movement, the level of service deteriorates very fast at a much lower volume, only 842 vehicle per hour the volume. So, that is not very high. Still the operation is poor, and both ATS and PTSF are at unacceptable level with 38.6 mile per hour and 81.8%. So, the directional flow we said 842, right. So, with 842 this much direction flow in one direction itself, the level of service is deteriorated so fast. So, obviously, these segments need to be examined for potential improvement. That could be the recommendation, because it is already operating at LOSE. So, what we discussed in this case is I explained to you the framework for LOS determination for different classes, class 1, class 2 and class 3, and the computational steps in details. I have described how you calculate, how you refer to different exhibits in highway capacity manual, and pick up the appropriate values. And then I have taken one example problem of class 1 to 2-lane highway segments to show you, given all the data, how actually you can calculate the LOS, and to conclude also that for 2-lane 2-way highway segments, even at a much lower volume itself, the level of service deteriorates very fast. With this, I close this lecture. Thank you so much.